everybody. In this video, let us know about the theorems on probability. So, addition theorem and multiplication theorem. First, addition theorem or theorem on probability. If we take two events A and B, they are mutually exclusive. They are mutually exclusive. Then the probability of occurrence of that events is written as A or B. Is the sum of probabilities of A and B. That is, we can write as probability A or B, or we can write it as probability A plus B. Addition we are doing. Or we can write the probability A union B. Comes out to be P of A, the probability of A event to occur plus probability of B event to occur. Alright. Now here, mutually exclusive means if we take one coin, okay, coin has one head, one tail. When you toss the coin, what happens? Either you will get head or tail. Whether both will come? Impossible. Either you will get head or tail. Right? And now, such means any one event only occurs. Here two events will not occur. Any one event will only occur. So that we call it as mutually exclusive probability. Only one event will occur. Either this or this. That we call mutually exclusive probability. Now next, for a more understanding, let us do a problems on this, an example problems. Okay. So the first one is when coin is tossed, okay, either head or tail is appeared. We know that either head or tail appears, right? Now the question is, what? Let us take a dice. Even in the dice also. So what is probability of dice showing 2 or 5? Dice showing 2 or 5. Dice means, you know, no, 1, 2, 3, 4, 5, 6 will be there. Okay, you have seen the dice, no? So 6 will be there. Now here, the probability of getting 2. So only one chance is there. 1 dot, then 2 dots, 3 dots. Dice you will see, no? Only one chance is there of getting probability 1. Now divided by number of favorable events. How many are there? 6 are there. Right? So actually how we will write? Favorable events divided by total number of favorable events. Favorable events only 1, 2 will be there. Okay. Now if we do 1 plus 2, only 1, 2 will be there. So 1 is the favorable event by 6 total number of favorable events. Similarly, if we write the probability of 5, it is also 1 by 6, only 1 5 is there. Favorable events 1 and total number of events, how many are there? 6. Right? So now how we will write? P 2 or 5. Formula is P of A plus P of B, no, P of 2 plus P of 5. Right? So now what we will get? 1 by 6 plus 1 by 6, 2 by 6. Answer is 1 by 3. So here only one event occurs. Right? Now let us go for the next example. So now here, what is the probability of randomly picking numbers 1 to 10 that is even and 1 to 10 that is odd. Okay, so 1 to 10 he is saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Picking of even numbers, probability of picking of even numbers, P even. How many even numbers are there? 2, 4, 6, 8, 10. 1, 2, 3, 4, 5. And number of favorable, the total number of events up to 10 he gave. So what are even numbers? 2, 4, 6, 8, 10. Similarly odd. Odd, how many we will have? 1, 3, 5, 7, 9, 3, 5. 4, 5. And favorable total number of events 10. Right? Now he is saying that randomly picking even or odd. Randomly picking even or odd. How we will write? 5 by 10 plus 5 by 10. P of even plus P of odd. That is what we will get. So 10 will be the LCM. 10 by 10. 1 we will get. Right? Now next, in the same addition theorem, we will have, this is mutually exclusive one. We will write, what we will write? P of A plus B equal to P of A plus P of B. Mutually exclusive. Now there is, in some particular cases, not mutually exclusive. Not mutually exclusive means, suddenly sometimes two events, so the outcomings will be favor in two events. So two events may occur. Okay. So in such a position, what we will write here? Two events will occur. That is P A plus B or A or B or A union B is equal to P of A plus P of B minus P A intersection B. A intersection B means here two events are occurring. One is dependent on other. Two events are occurring. Here chances are there. Our events are in such a way that outcomes are favor in A as well as B. Okay. Now to understand, that is both A and B happens together. In before we said any one will happen. But here A and B happens together. Then that we call not mutually exclusive. So now for that we are taking one example to understand that. So now here what is happening? One may affect other. Okay. One may affect other simultaneously. So now a bag contains 10 balls, of which 5 are red. Okay. Now 3 are yellow. Okay. 2 are black. Right. Now what is probability that ball drawn are one red, one yellow and one black. Okay. One red, one yellow and one black. Now let us see. Here what he is saying? He is saying that a bag contains A bag contains some 5 red, okay, 3 yellow, 2 black, right? 3 yellow, 2 black. Sorry, let us take some other example. So here I am taking some other example depending on this, such as a card. This is for with replacement question I wrote by mistake. A card is drawn from standard deck of cards. Okay. Find probability of selecting either 2 or a heart. Right. Now, standard deck of cards. How many you will have? Generally 4 types of playing cards you will have, no? One we will call spade, black color, club, black color, heart, red color, diamond, red color. Right? The 4 types of playing cards. In spade, we will see 13 cards. Here also 13 cards. 13 cards, 13 cards. In this 13 card, a king, queen will be there. Ekka we will say, no, Ekka will be there. Right? Now first, he is saying to find the probability of selecting either 2 or a heart. So first, probability of selecting 2, let us write. Right? So now here, in spade we will find 2, in club we will find 2, in heart, in diamond also we find 2. How many 2s are there in this standard deck of cards? 4 2s are there. So favorable events 4. Now total number of favorable events 13 plus 13 plus 13 plus 13, 52. Right? Total favorable events 52. Similarly, finding the heart. Okay. So now here this is heart. How many cards will be there? 13 favorable events. And out of this standard deck of cards only, no. So total events are 52. Next, what he is saying, the probability of finding 2 or a heart. Then what will be the formula? P of 2 plus P of heart minus. Now in heart also you are having 2, no? Right? In heart also you will have 2, no, in these 13 cards. Ekka, 2, 3, 4, in such a way we will get, no. Means in heart you are finding 2 things. One is 2 you will find as well as heart. So minus, we will write A intersection B. That is A as well as B, both are there in heart. Heart is there, 2 is there. Right. So now P of 2, 4 by 52 plus 13 by 52 minus. Then what is the probability? In the heart only. Now PA2 intersection H we have to write, no. In heart only we are having 2. So only one event will be there. And as usual, total number of events 52. 1 by 52. On solving, we will get 16 by 52. Alright. Now, this is about not mutually exclusive. So, here in some cases, both may occur. Now, here see, in heart 2 will be there. Right? In hearts 2 will be there. In the playing cards, hearts 2 will be there. So, 2 is there, H is there. But only 1 2 is there, favorable event 1 by total number of events 52. So substituting the formula, how we will get this, right? Then similarly, now we can also take some other examples. Okay, let us do some other examples. Now some students or patients you think went for public health center. Okay, now they went for some different treatments. In that clinic, 15% of patients so did dental exam, went for checking their teeth, dental exam. Now next, 45% of patients went for physical exam, and 5% of people, they went for both dental exam as well as physical tests. Right. Now he is asking to find if the patient's record is selected suddenly randomly, then what is the probability of patient received either dental exam or physical test, he is saying. Right. So first, either dental or physical test, what we will write? Same formula, P dental plus P physical minus P dental and physical. So that is equal to P dental, how much he said? 15%. P physical 45%. P dental and physical both what he said? 5%. So the answer will be 55%. So in such a way, we have to do, we have to understand the question whether he is asking the exclusive or not mutually exclusive. And depending upon, you just do the problems. Now next, let us go for multiplication theorem. Okay. Here also we will find two kinds. One is the independent events, other is the dependent events. Right. So first let us go for independent events. The formula is both events are there, A and B. P, A, probability of A and B. We will write as probability of finding the event A into probability of finding event B. Right? Or we can also symbolize it as AB, nothing but A intersection B. P of A, P of B. Okay. Now here, A and B he said. Now let us take one example. Now two coins he took. He tossed simultaneously. Two coins he tossed. So coin 1 showed, for example, you think head. Coin 2 tail. Right. In the case of coin 1, the probability of finding head is of 1/2 chances only, because tail is also there, no. And here the probability of finding tail is also in this coin 1/2 chances only. Right. So now probability of finding head and tail, what we will write? P of head into P of tail, that is equal to 1/2 into 1/2. Answer comes out to be 1/4. Right. In a similar manner, let us see some other example for the better understanding. So now he took, let us think that we took 2 packets of playing cards. Okay, standard deck only we took. So spade, club, heart and what will be there? Diamond in standard deck. So now he is taking to take either ekka from one packet, ekka from one packet or packet 1 you think, no? And king from second packet or another packet. He is asking the probability of taking ekka from one packet, king from another packet. So first, the probability of finding ekka. So in a standard deck, how many ekkas will be there? 4. And favorable total events 52. Right? Now similarly, finding the king, how many kings will be there? In spade 1, club 1, heart 1, diamond 1, 4 kings. Total favorable events 52. Now finding, here 2 events are occurring. From one packet we are taking ekka, from other packet we are taking king. So 2 events are occurring. Right? Now what we will write? 4 by 52 into 4 by 52. So if we solve, we will get 1 by 169. So these are independent events. Okay. From this one, you here for multiplication, remember that we require 2 events. For multiplication, we require 2 events. For addition, we require only 1 event. 1 event only occurs. But here we require 2 events. From here 1 you are getting, from here 1 you are getting. So the formula comes out to be this into this. Right. Now next, let us go for dependent events. Dependent events means one event affects the probability of other. Okay. One event affects the probability of other. Now let us write a question. Now a bag contains, so first formula how we will write means P, A and B is equal to probability of finding event A into probability of B by A I dot. Means here this B by A, how we will study means the probability of B when A has already occurred. If you see this example, you will understand this. So a bag contains, now this is one particular bag. What he is saying? 10, totally 10 balls are there in the bag. Okay. Out of that 10 balls, 5 are red balls, 3 are yellow balls, 2 are black balls, right? 2 are black balls. Okay. Now here we are drawing 3 balls are drawn. So what is the probability of the ball drawn? So now he is asking what is the probability of drawing one red, okay, one yellow and one black. Here 2 conditions will arise. Here one bag, what we said, one event affects the probability of other, and this is the formula I say. Right? Here in 2 ways we will talk about the multiplication theorem. One is with replacement, other is without replacement. First let us see with replacement. With replacement is nothing but equivalent to the independent events which we talked before. Now only we completed independent events and came to dependent. No. So with replacement will be equivalent to the independent events. Right? So here first let us write the probability of red balls. How many red balls are there? 5. And how many balls he drawed? He is saying 1 red ball. He took out the red ball and again he replaced, means again he put that red ball in the same bag. Then will the probability affect? No, because he took and again he placed. So the total favorable events are 10. Total balls 10. Now next, similarly, the probability of finding the yellow ball. How many yellows are there? 3. He took one yellow ball and again placed in the same bag. So probability will not disturbed. So 3 by 10. Again, he took one black ball. The probability, how many black balls are there? 2 favorable events. And he took and again he kept in the same bag. So probability will not be affected. Right? So 2 by 10. So this is equivalent to independent events we are saying. So P, how we will write? P of R into P of Y into P of B. 5 by 10 into 3 by 10 into 2 by 10. 2 5s are 5. So 3 by 100. Right? Here we are replacing. We are taking out the ball. Again what we are doing? We are placing that ball in the same bag. Now next condition comes to be without replacement. Without replacement. With replacement is equivalent to the independent events. That formula only we will use. Now for without replacement we will use this formula. Is equal to, now 3 are there, no? So I will write it as P, A, B and C. So P of A into P of B by A into P of C by AB. Okay. Now P of B by A means probability of B when A has already occurred. Right? P of C by AB is probability of C when A and B had already occurred. Right? Now if you see the problem, I am applying this to the same problem. Okay? In bag, what we are having? 5 red balls, 3 yellow balls, 2 black ball. Means total balls 10. So he is removing one red, one yellow, one black ball. But he is not replacing. He kept near him only. Again he did kept in the bag. So first, for probability of R, let us write now. How many R are there? 5. How many number of total events? Favorable events? 10. Right? Now probability of yellow I am writing. One yellow ball he took. Right? One yellow ball he took. Actually how many yellow balls are there? 3 are there. One yellow ball he took. Means actually totally with these 3 yellow balls only, total balls became 10, no? Now he removed one yellow ball. How many balls will remove? 9 balls. Means this probability is affected by the removing one yellow ball, no? Right? Sorry, I removed one red ball. First I wrote the total. Now I removed one red ball. So out of 5 I removed one, means 4 red balls are in bag. So now how many total balls will be there? 9. Now if I write the yellow ball probability, what I will get? Actually 3 yellow balls. But I removed one red ball, no? Means the total favorable events will be, or total balls in the bag will be 9. So now the probability of yellow is affected by the removal of one red ball, no? This we call it as dependent events. What I said, the one event affects the probability of other, I said. By removal of one red ball, the probability of other is affected. It became 3 by 9. Now next what I am doing? I want to write the probability of black balls. So now here How many black balls are there? 2. Now again what I did here, I removed one yellow ball. Okay, already one red ball has removed, it became 4. I kept near me, I didn't replace it. Now one yellow ball has remained. So now how many yellow balls are there in back? 2. So total balls becomes 4, 5, 6, 7, 8. Means total balls now 8. By removing of yellow ball, now the probability of black ball has affected, no? It became 2 by 8. Now the formula is P of A into P of B by A into P of C by AB. I said, what is P of A? P of A means here R, and here, okay, I am writing the same formula in these terms. P of R into P of Y by R into P of B by YR. In the same pattern I wrote. Here P of R is 5 by 10 into P of Y by R. The probability of Y when R has already occurred, no? 1 I removed. It converted into 4. R already occurred. So R already occurred, that is 3 by 9. Now here I removed one yellow ball as well as red ball, both. Now I got the black ball probability, that is 2 by 8. Right? Now answer comes out to be 3 3s are 9, 5 2s are 10, 2 2 strikes off, 1 by 8 3s are 24. So in such a way, with replacement and without replacement, we will do dependent events. So when you do the dependent events, you have to read the question whether it is with replacement or without a replacement. Thank you for watching my video. So if you like my video, like it, share it, subscribe with it. Stay with my channel Reshma Physics. Thank you.